Hello students, welcome to this lecture, one pair of linear equations. In this lecture, we will cover previous year questions. Okay, one pair of linear equation in two variables. So let's get started. So this is our question number 1. In question number 1, we have given this question. If the equations kx minus 2y, this is equal to 3 and 3x plus y, this is equal to 5, represent two intersecting lines at a unique point. Then we need to find the value of k. So here, what is the value of k? Basically, we have given two linear equations. Okay, and we have given also these two linear equations represent two intersecting lines at unique point. Okay, that means this pair of linear equations will have a unique solution. Okay, so student, if you remember, for the pair of linear equation, the lines are intersecting at exactly at one point when a1 by a2, this ratio does not equal to b1 by b2. Okay, so if we use this condition, then we can find the value of k. So let us see how to solve. So here we have given this linear equation and this linear equation, and here we also have said these two linear equations represent lines intersecting at a unique point. Okay, and we know the general form of a pair of linear equation, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay, so now if we compare the coefficients of this given equation with the general form, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then you will get the value of a1, this is equal to k, and the value of b1, this is equal to minus 2, and the value of c1 is equal to minus 3. Okay, and the value of a2, this is equal to 3, the value of b2, this is equal to 1, and the value of c2 is equal to minus 5. So if we use this condition, a1 by a2, this is not equal to b1 by b2, then we get this relation k by 3, this does not equal to minus 2 upon 1. Okay, and now if we simplify this not equal equation, okay, this unequal equation, so then it implies k does not equal to minus 6. Okay, so for any value, any real number except k is equal to minus 6, the given pair of linear equations represents line intersecting at a unique point. Okay, so except k minus 6, for any real number for any value of k, where k is any real number, okay, the given equation represent two intersecting line at a unique point. Okay, so now I move to the question number 2. So in question number 2, here we have to basically find the value of k, for which the system of equation x plus y minus 4, this is equal to 0, and 2x plus ky, this is equal to 3 has a unique solution. Okay, so first of all, you have to rewrite the given equation in the form of a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay, then you need to find the values of a1, b1 and c1 and a2, b2 and c2. Okay, then next you have to find the values of a1 by a2, b1 by b2 and c1 by c2. And you know the system of equation has a unique solution when the ratio a1 by a2, this is not equal to b1 by b2. Okay, so here now let us see how to solve this problem. Okay, so we know when for no solution we know this condition. Okay, but here we need has a unique solution. Okay, for unique solution we know a1 by a2, this does not equal to b1 by b2. Okay, and that is 1 by 2 does not equal to 1 by k. Okay, and that is k does not equal to 2. So the value of k does not equal to 2, for which the system of equation x plus y minus 4 is equal to 0 and 2x plus ky is equal to 3 has a unique solution. Okay, so for this question, option number B is correct answer. Okay, the correct answer is option number B. Now let us move to question number 3. So in question number 3 we also find the value of k, for which the pair of linear equation x plus y minus 4 is equal to 0 and 2x plus ky minus 3 is equal to 0 have no solution. Okay, so student, what we know about when a pair of linear equations have no solution? That case we can compare the given equation with a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay, then if we compare this equation with that general form, then we'll get the values of a1, b1 and c1 and the value of a2, b2 and c2. Then we can find the ratio a1 by a2, b1 by b2 and c1 by c2. And for no solution of a pair of linear equation, a1 by a2, this is equal to b1 by b2 but does not equal to 1 by c2. Okay, so here we'll use this condition and then we will find the value of k. So let us see. So for no solution we know a1 by a2, this is equal to b1 by b2 but does not equal to c1 by c2. Okay, and if we compare the given equation with the general form of pair of linear equations a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then you will get the value of a1 is equal to 1, b1 is equal to 1 and c1 is equal to minus 4, and the values of a2 is equal to 2, the value of b2 is equal to k and the value of c2 is equal to minus 3. Okay, so if we now find the ratio, then a1 by a2, this is basically equal to 1 by 2 and b1 by b2, this is equal to 1 by k and c1 by c2 is equal to minus 4 upon minus 3. Okay, so 1 by 2, this is equal to 1 by k but does not equal to minus 4 upon minus 3. Okay, and now if we take this equation 1 by 2 is equal to 1 by k, then we'll get the value of k, that is basically equal to 2. So the value of k is equal to 2. So now if we back to the question, then here we will see in option B we have given 2. Okay, so for value of k is equal to 2, for which pair of linear equation x plus y minus 4 is equal to 0 and 2x plus ky minus 3 is equal to 0 have no solution. Okay, so for question number 3, here the correct answer is option number B. Okay, so now let us move to next question. So in next question, here we have the perimeter of a rectangle whose length L is 4 centimeter more than twice its breadth. B is 14 centimeter. Okay, the pair of linear equation representing above information is what? So here we have given 4 options. So among these 4 options, which option will be correct? That we'll have to find. Okay, so here basically we have given a rectangle and we have given this information the length of this rectangle is basically 4 centimeter more than twice its breadth. Okay, so here we will get one condition, that is length L, this is equal to 2 times breadth B plus 4. Okay, so we'll get L, this is equal to B 2B plus 4, and we know perimeter. So here we have given perimeter is 14 centimeter. Okay, so we know the perimeter of rectangle is basically 2 times length plus breadth. Okay, so 2 times L plus B, this is equal to 14. So let us see first solution. So we know perimeter 2 times length plus breadth, that is equal to 14, and here we have given the condition length is more than 4 or twice of its breadth. Okay, then we'll get this equation L is equal to 2B plus 4. And if we now check the option, then in option D we have given this information, L is 2B plus 4 and 2 times L plus B, this is equal to 14. Okay, so the pair of equations representing the above information is in option D. Okay, so here the correct answer for this question is option number D. Now let us move to question number 5. Okay, so in question number 5 we need to find the solution of the pair of linear equation x is equal to minus 5 and y is equal to 6. Okay, so here we have given in four options ordered pair. Okay, so here this value is for x and this value for y. We know one, we have studied in our class 9th coordinate geometry. There we have studied about the coordinates. Okay, so in coordinates the first element is called x coordinate and the second element is called y coordinate. Okay, so basically we have given a pair of linear equations, x is equal to minus 5 and y is equal to 6, and here we need to find the solution of the pair of linear equation. So basically we can find the solution of the pair of linear equations by using graphically. Okay, so here if we draw the graph of this pair of linear equations, suppose you have this coordinate system. Okay, this is y axis and this is x axis. Okay, and here my minus 1 is here, minus 2 is here, minus 3 is here, minus 4 is here, minus 5 is here. Okay, and here 1, here 2, here 3, here 4, here 5, and so on. Here 1, here 2, here 3, here 4, here 5, and so on. And here minus 1, here minus 2, here minus 3, here minus 4, and so on. Okay, so x is equal to minus 5 is basically will be here. So this is our x is equal to minus 5 point. Okay, and x is equal to minus 5, this line represented by this graph. Okay, so this is the graph of equation x equal to 5. So this is the graph. This is the graph of the equation x is equal to minus 5. Okay, this is parallel to y axis. Okay, and the graph of y is equal to 6 is basically a line which is parallel to x axis from the distance of 6 units along the positive directions of y axis. Okay, so you can think this line. Okay, so this line is basically the represented the equation y is equal to 6. So the equation y is equal to 6 represented by this line. Okay, and these two lines intersect at some point here. Okay, and this point, the coordinates of this point is basically minus 5 minus 5 comma 6. Okay, so the coordinates of the intersecting point are minus 5 comma 6. Okay, so minus 5 comma 6 is the solution of the pair of linear equations x is equal to minus 5 and y is equal to 6. So here in this question, the correct answer is option number A. Okay, so option number A is here correct answer for this question. Now let us move to question number 6. So in question number 6, here we need to find the value of k for which the pair of linear equations px plus 5y is equal to 8 and kx plus 15y is equal to 24 has infinitely many solutions. Okay, so basically we need to find the value of k, and we have given this pair of linear equation. Okay, so here this pair of linear equations has infinitely many solutions. Okay, so then what is the value of k? So here we have given this in this question 4 options. So among these 4 options, which options will be correct, that we will have to find. Okay, so now we can solve this problem like in this way. Okay, so for infinitely many solutions, we know this condition a1 by a2, this is equal to b1 by b2, this is equal to c1 by c2. Okay, so if we have a pair of linear equations in the form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay, then for infinitely many solutions, we know this condition hold. A1 by a2, this is equal to b1 by b2, this is equal to c1 by c2. Okay, so now if we compare the given equation, if we compare the coefficients of the given equation with the general form of a pair of linear equation a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay, then we'll get the values of a1 b1 c1 and a2 b2 c2. Okay, then we can find the ratios a1 by a2, b1 by b2 and c1 by c2. So a1 by a2, this is equal to 3 by k, and the b1 by b2, this is equal to 5 by 15, and the value of c1 by c2 is equal to 8 by 24. Okay, so now if we equate them, then we will get this equation, and if we now solve this equation, then we will get the value of k. So if we solve this equation, then we will get the value of k is basically equal to 9. Okay, and in option B, we have given the value of 9. Okay, so here for this question, the correct answer is option number B. Okay, so option number B is correct answer for this question. So I hope you understand this problem. So I move to the question number 7. So in question number 7, here we need to find the values of x and y that satisfying the two equations 32x plus 33y, this is equal to 34, and 33x plus 32y is equal to 31 respectively. Okay, so student, here for finding the values of x and y which satisfying the given equations, we can use here elimination method for finding the solution. Okay, for finding the solution of this pair of linear equation. Okay, so here if we naming this equation 32x plus 33y, this is equal to 34. Okay, this is naming as equation number 1, and 33x plus 32y, this is equal to 31, and naming this equation number 2. And now if we adding equation number 1 and equation number 2 and subtracting equation 2 from equation 1, then we get 65x plus 65y, this is equal to 65. Okay, or x plus y, this is equal to 1, and minus x plus y, this is equal to 3. Okay, so here we get another two equation, x plus y, this is equal to 1, and minus x plus y is equal to 3. Okay, so naming this equation number 3, and this equation is equation number 4. And now if we adding equation number 3 and 4, then we get the value of y. This is equal to 2. Okay, so the value of y is equal to 2. Now substituting the value of y in equation number 3, then you will get the value of x is equal to minus 1. Okay, so the values of x and y are basically x and y respectively are minus 1 and 2. Okay, so minus 1 is for value of x and 2 is for the value of y. Okay, so therefore the solution for this given pair of linear equation is x is equal to minus 1 and y is equal to 2. Okay, so in option A you can see here this is given. Okay, so for this question here the correct answer is option number A. Okay, so now let us move to question number 8. So in question number 8 we have given pair of linear equation x minus y, this is equal to 1, and x plus ky, this is equal to 5. Okay, and if the pair of linear equation which is given in this question has a unique solution, x is equal to 2 and y is equal to 1. Okay, then we need to find the value of k. So basically here we have to find the value of k. Okay, so here we have given 4 options. In these options, among these options, here we have correct answer. Okay, for the value of k. So here basically we have to find the correct option. Okay, so basically we have given this information. This pair of linear equations has a unique solution. Okay, and that solution basically is x is equal to 2 and y is equal to 1. Okay, so what is the definition of a solution of a pair of linear equations? So we know if the solution x is equal to a and y is equal to b satisfy the given 2 equations, that is both if satisfied by this solution in both equation, then that values are called solution of that pair of linear equations. Okay, so here x is equal to 2 and y is equal to 1, these values must be satisfied this given pair of linear equation. Okay, so basically we can substitute the value of x is equal to 2 and y is equal to 1 in equation number 2. So here we can substitute the value of x is equal to 2 and y is equal to 1. Okay, so if we substitute the value of x is equal to 2 and y is equal to 1 in this given equation, then basically we can find the value of k. So let us solve step by step. So here we have given this pair of this linear equation x plus ky is equal to 5. Okay, so now at x is equal to 2 and y is equal to 1, here this equation will become 2 plus k times 1, this is equal to 5. Okay, and now if we simplify this, then we'll get the value of k is equal to 3. Okay, so the value of k is equal to 3. So if the pair of linear equation x minus y is equal to 1 and x plus ky is equal to 5 has a unique solution, x is equal to 2 and y is equal to 1, then the value of k is equal to 3. Okay, so here option C is correct answer. So now student, let us move to question number 9. So in question number 9 we have given the pair of linear equation x plus 2y plus 5 is equal to 0 and minus 3x minus 6y plus 1, this is equal to 0. Okay, here we have to find which type of solution we'll have for this pair of linear equation. Okay, so here we have given 4 options. In option A we have given a unique solution. In option B we have given exactly 2 solutions. In option C we have infinitely many solutions. In option D we have no solution. So student, how can we find whether this pair of linear equations has a unique solution, exactly 2 solutions, infinitely many solutions, or no solution? Okay, so let us solve. So we know for unique solutions, this condition must be hold. A1 by A2, this is equal to B1 by, this does not equal to B1 by B2. Okay, for unique solution, this condition must be hold. Okay, and for infinitely many solution, this condition hold. A1 by A2, this is equal to B1 by B2, and this is equal to C1 by C2. Okay, and for no solution, A1 by A2, this is equal to B1 by B2, but does not equal to C1 by C2. Okay, so here you can first compare this linear equation with the general form of linear equation, pair of linear equations A1x plus B1y plus C1 is equal to 0, and A2x plus B2y plus C2 is equal to 0. Okay, then we'll get the values of A1, B1 and C1, and A2, B2 and C2. Okay, so if we compare, then we'll get the value of A1 is equal to 1, B1 is equal to 2, and C1 is equal to 5. Okay, and the value of A2 is equal to -3, B2 is equal to -6, and C2 is equal to 1. Okay, now the ratio A1 by A2, this is equal to 1 by -3, and the ratio B1 by B2, this is equal to 2 by -6, and the ratio C1 by C2 is equal to 5 by 1. So here you can see the ratio 1 by -3, this is equal to 2 by -6, but does not equal to 5 by 1. Okay, so here basically this condition hold. A1 by A2, this is equal to B1 by B2, but does not equal to C1 by C2. Okay, so the given pair of linear equations has no solution. Okay, so here for this question, correct answer is option number D. Now let us move to question number 10. So in question number 10, we have given this pair of linear equations, and here we have to actually check the pair of linear equations. How can we graphically represent this pair of linear equations? Okay, so the pair of linear equations represents two lines which are actually whether intersecting or parallel or coincident, or either intersecting or parallel, that we have to check. Okay, so here we can first rearrange this linear equation. Okay, so we'll first rearrange this linear equations as 2x minus 5y minus 6 is equal to 0, and minus 6 plus 15y plus 18 is equal to 0. Okay, and here if we compare this equation with the general form of the pair of linear equations, a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. Okay, then we'll get the values of a1, b1 and c1, a2, b2 and c2. Okay, then the ratios a1 by a2, this is equal to 1 by 3, b1 by b2, this is equal to minus 1 by 3, and the c1 by c2 is equal to minus 1 by 3. Okay, so here you can, this is also minus 1 by 3. So here you can observe that the ratios a1 by a2, this is equal to b1 by b2, and this is equal to c1 by c2. Okay, so here a1 by a2, this is equal to b1 by b2, and this is equal to c1 by c2. Okay, so the pair of linear equations will have infinitely many solutions. That means the pair of linear equations are coincide to each other. Okay, so the pair of linear equation 2x is equal to 5y plus 6 and 15y is equal to 6x minus 18 represents two lines which are coincident. Okay, which are coincident. So here the correct answer is option number C. Now let us move to question number 11. So in question number 11, we have given this problem. Okay, so in this problem, it said a father's age is 3 times the sum of the ages of his 2 children. Okay, after 5 years, his age will be 2 times the sum of their ages. And here find the present age of the father. Okay, so here we have given two information. First information is father's age is 3 times the sum of ages of 2 children. Okay, and after 5 years, his age will be 2 times the sum of their ages. Okay, so let us solve. So here we can first let the present age of the father be x years. and the sum of the present age of his two children be y years. Okay, so now according to question, x is equal to 3y, and if we rearrange this equation, then it implies x minus 3y is equal to 0. Okay, so it implies x minus 3y is equal to 0, and after 5 years x is equal to x plus 5 is equal to 2 times y plus 10. So here basically after 5 years we will get this equation x minus 2y is equal to 15. Okay, so x minus 3y is equal to 0 and x minus 2y is equal to 15. Now you can solve this equation. So subtracting equation 1 from 2, then we get x minus 2y is equal to 15 and x minus 3y is equal to 0. When subtracting, then we get the value of y is equal to 15. Okay, and once substituting the value of y is equal to 15 in equation 1, then we get the value of x is equal to 45. Okay, so hence the present age of the father is 45 years. Okay, now let us move to question number 12. So in question number 12, it said to us a fraction becomes 1 by 3 when 2 subtracted from the numerator, and it becomes 1 by 2 when 1 is subtracted from the denominator. So find the fraction. So let us solve. So here we first let the numerator of the required fraction be x and the denominator of the required fraction be y, where y not equal to 0. Now according to question, x minus 2 over y, this is equal to 1 by 3, and if you simplify this, then you will get the equation 3x minus y is equal to 6. Okay, and thus from the second condition, the fraction x over y minus 1, this is equal to 1 by 2, and it implies 2x is equal to y minus 1, and it implies 2x minus y is equal to minus 1. Okay, so here we get two linear equations, 3x minus y is equal to 6 and 2x minus y is equal to minus 1, right? So now we can solve this two linear equation by using elimination method. Okay, so once subtracting 2 from 1, then we get the value of x is equal to 7. Okay, and once substituting the value of x equal to 7 in equation 1, we get the value of y is equal to 15. So hence the required fraction is basically x over y, this is equal to 7 by 15. Okay, so now let us move to question number 13. So in question number 13, it said if we add 1 to the numerator and subtract 1 from the denominator, a fraction reduces to 1 and it becomes 1 by 2. And if we only add 1 to the denominator, then it becomes 1 by 2. Okay, so what is the fraction? Okay, so here let the required fractions be x over y. So according to given information in question, we can get this linear equation x plus 1 by y minus 1 is equal to 1, and if we simplify, then it is equal to x is equal to y minus 2. Okay, and also x by y plus 1 is equal to half, and it implies 2x is equal to y plus 1, and then this equals 2. Okay, now from equation 1 and 2 we get the value of y is 5, and if we substitute the value of y is equal to 5, then we'll get the value of x equal to 3. Okay, so required fraction x over y is equal to 3 by 5. And for second question, so in second question we have, for which value of k will the following pair of linear equations have no solution? Okay, so we have given this pair of linear equations, and here we have to find the value of k. So let us see. So here for the no solution, we know a1 by a2, this is equal to b1 by b2, but does not equal to c1 by c2. Okay, so if we use this condition, then we get this equation 3 over 2k minus 1, this is equal to 1 by k minus 1, does not equal to 1 over 2k plus 1, and it implies 3 over 2k minus 1, this is equal to 1 over k minus 1, and it implies 2k minus 1, this is equal to 3k minus 3, and it implies k is equal to 2. So therefore the value of k is equal to 2. So I stop here this lecture. Thank you very much to all of you.